Since ancient times, mathematicians studying the circle have recognized that the ratio of its circumference to its diameter gives a constant value. This is pi, which is an irrational number. The ancient Babylonians and Egyptians were known to use values around 3 as approximates of pi, but it was Archimedes who came up with the first theoretical method for the calculation of pi. He used regular polygons to approximate the measurements of a circle. As the number of sides of the polygon increases, the approximation gets better. With a 96-sided polygon, Archimedes was able to calculate that pi was between 223 over 71 and 22 over 7. You can try approximating the value of pi for yourself. Find circular objects around your home like buttons, bottle lids, and plates. Run a piece of string around the circumference of the object and lay the string on a ruler to find a value for the object's circumference. Divide this value by the diameter of the object to get your approximation of pi. At the present time, pi has been accurately calculated to thousands of decimal places. However, for daily work, pi is often taken as 3.14, or 22 over 7. Now that we know the value of pi, the circumference of a circle with radius r can be easily calculated with the following formula.
One day in an art class, some students decide to use strings to make pictures out of circles of different radii. Help the students to calculate the amount of string they need to form the circles in the following pictures.
The carousel in the fairground consists of a circular centerpiece of 10 meters radius that rotates at a constant speed of 4 meters per second. There are individual circular carriages of 1 meter radius attached to the circumference of the centerpiece. Each of them rotates independently at a constant speed of 0.5 meters per second. If the centerpiece of the carousel rotates for 12 complete revolutions, how many revolutions does each individual carriage perform during the duration of the ride? How can a circle be transformed into a parallelogram? Click on the button provided to see. We have obtained a crude parallelogram with its height equal to the radius of the original circle. Notice that the base of the parallelogram is formed by small arcs of the circle. Can you write an expression relating the base B to the radius R of the circle? Click the button provided to check if your answer is correct. If the number of pie slices increases infinitely, the base length will become closer and closer to a straight line, and the figure will eventually become a parallelogram. Do you know its area? Can you deduce the area of the original circle? Concentric circles are the circles with same center but different radii. This diagram shows 2 concentric circles. What is the ratio of the area of the smaller to the bigger circle, given different lengths of radii? Examine the data in the table. Can you generalize a formula for finding the ratio in areas of the 2 circles? circles? What is the area of the ring in terms of the two radii? The diagram is formed by two squares of different sizes and one circle. What fraction of the diagram is white? Take pi to be 22/7. We can divide the inside square into 4 right triangles of equal size. The dotted lines are actually the diameters of the circle. Hence, 2 out of 3 sides in each right triangle are 10 divided by 2 equals 5 centimeters. Can you find the area of the inside square? What is the area of the circle? By subtracting the two areas, we can get the area of the white portion. What is the fraction of the white portion? A chord joins 2 points on the circumference of a circle. The chord divides the circle into 2 segments. The larger one is the major segment, while the smaller one is the minor segment. Sectors are formed between 2 radii of the circle. The bigger sector is the major sector, while the smaller sector is the minor sector. An arc is a curved part of a sector. The major arc comes from the major sector, while the minor arc comes from the minor sector. Drag the following words to the correct places in the diagram given. Now help the mechanic to replace the missing wheel on the car by dragging the different components of the circle into their correct places. Can you remember the formulae for the area and the circumference of a circle? Let's use these 2 formulae to find the length of arc and the area of sector in each of the following cases. Let's now examine this table. A pizza parlor is having a promotion in which they sell the following pizza slices for $2 each. Help John to decide which pizza slice is the best buy by sticking a flag into it. The next day, the pizza parlor has a different promotion in which they sell the following slices of pizza for $2.50 each. John's friend Ramu visits the pizza parlor. Ramu only likes to eat the crust of a pizza. Help him to decide which pizza slice is the best buy by sticking a flag into it. Wei Ming has a full schedule to keep him occupied after school. As Wei Ming performs each of his activities, calculate the area swept through by the minute hand of the various timepieces that keep track of his time. Leave your answers in terms of pi. The diagram shows two circles of same radius 7 centimeters. What is the perimeter of the shaded region? Take pi equals 22/7. Triangle ABC and triangle ABD are equilateral triangles. What are the sizes of angle CAD and reflex angle CBD? Can you find the lengths of the minor arc CBD and the major arc CED? What is the perimeter of the shaded region? We can also use the symmetrical property to solve this problem. Observe that these two minor arcs are equal in length. Hence, the perimeter of the shaded region is actually the circumference of the circle with radius 7 centimeters.